Hello everyone, welcome to the short course video series. I'm Binod Srinivasan and I'll be your instructor for this course on Linux Unix Primer. The goals of this course, especially this specific hands-on training video, are to provide you with an essential understanding of the shell environment, gain basic understanding of Unix commands and utilities. Most importantly, by the end of this Linux Primer series, help you gain more confidence in writing shell scripts that would encapsulate your end-to-end data processing framework. The video presentation offers a look and feel as well as a hands-on exposure to performing Linux operations from the command line. Kindly stay tuned to the Linux Primer cookbook that is attached to this training web page, as it will be updated with more exercises and code snippets. As far as the prerequisites for this specific training session is concerned, in order to successfully complete the training exercises, you would like to make sure you have access to a Linux or a Unix-based framework. Most essentially, you need access to a bash terminal to perform the instructions mentioned in the training video. As far as access to the bash terminals are concerned, most of the Linux and Unix-based operating systems come with a bash-based terminal. On Windows, you always have an option of installing a Unix-like environment, which also offers command line interface. The program that you typically use on a Windows machine is a Cygwin, which is a Linux emulator on a Windows platform. If you're a Mac OS user, which is already a Unix-based graphic operating system, it offers access to most of the Unix commands and functionalities you need to complete this training video, and as well as take the training contents to the next level. As far as the training agenda is concerned, we'll start out with the prerequisites. We already knew what prerequisites are required to successfully complete this training video, and we'll move on to discussing a little bit about Unix Linux history. And the next important topic of our discussion would be the concept of a shell. We'll look at what the functions of a shell is, what are the different types of shells available for your operating system, how do you use a shell, and how do you interact with a shell-like environment. And as the last part of this training video, you'll look at some hands-on utilities and hands-on commands that you can execute on a Linux-based terminal. A little bit of history about Linux and Unix. Shells are associated with different Unix and Linux operating systems. For example, the most common bash shell is often connected with Linux, and the Bourne and Korn shells are associated with AT&T's version of the Unix kernel. Unix was created to be a multitasking, powerful, and a versatile operating system that could run on hardware ranging from small form factor devices like your tablets or your phones to your large mainframe systems or even to supercomputers. Kernel, the code unit of Unix, is a framework that choreographs the interaction between the computing resources like memory, storage, and CPU on your machine with the supporting hardware systems. Since some of these tasks require a pathway of steps to be performed, the need for simple tools and utilities were warranted on a Linux framework. When interacting with the shell, all these commands and utilities are available to the end user. Shell allows the user to interact with the kernel by interpreting commands that can be invoked at the command line, or at the time of achieving automation, you could encapsulate all these commands into a script and execute the script instead of typing every single command again and again. As far as the functions of a shell is concerned, typically when you log on to a Unix-based machine, an interactive shell starts up and prompts user for input. Upon summation of a set of commands, the shell would parse it, create tokens and would search for that important command for its existence on your machine. If the command is installed on your machine, then it's going to get into a run state. If you are a first-time user of a Unix-based system, while getting familiarized with the commands and the command line mode of interacting, you'll be spending a good chunk of your time at the prompt. When a set of commands are executed more frequently, and when you see automation becoming a solution, you can bundle these commands into a file commonly known as a script and execute that script. Script execution guarantees step-by-step invocation of a list of commands that are presented in a certain sequence and that are written in a certain order, and most importantly follows a logic structure that is mentioned in the script. Writing scripts requires knowledge of existing utilities, commands, and the functions, as well as learning of programming constructs and logic techniques that can make a script more advanced. Types of shells. There are three prominent shells on any Unix-based system: the Bourne shell, the C shell, and the Korn shell. The interactive communication with all the three shells is the same, except that the syntax for writing the scripts is a little different. The common and the default Linux shell is called the Bash shell, which stands for Born Again shell. It's the most popular shell in Unix and Linux. Apart from Bash, other shell options for Linux users are the TC shell, which is a forked version or a branch of Unix C shell, and the Z shell. The default Bash prompt is a $. To know what shells are available for your version of Linux distribution and to get the path of each of these shells, there is a file which is within your Linux distribution that you can look at. And now we'll start doing some hands-on session. In order to know all the shell options available on your machine, you might want to start your terminal or the console first, and then there's a way you can look at the contents of a file using a command called cat, as in CAT. We'll dive a little deep into all these command options during the short course video, but to start off with, to just gain some understanding on all the shell options, let's go ahead and type this command CAT, as in cat, and we'd like to look at what's inside this file, etc shells. Well, you will notice that I just typed the first few letters in here and I used my tab button to do an autofill. Typically, Unix-based system would check and see if there are any files that follow a certain pattern. If that's the unique file available at a certain directory, it's going to autofill rest of the characters involved in that file name. Well, here the cat command on this shell file gave us several options. This tells us all the different shell options that are available on this specific hardware I'm using for today's presentation. Of course, the most common Bash shell is available, and we also looked at the Korn shell as well as the T shell options. Now that you've taken a look at a shell, let's see what a shell can do and why you would like to use a shell. Shell is the most powerful, efficient, and robust way of configuring your Linux experience. With just a set of commands and its performed operations, one can let the shell perform a plethora of tasks. It can range from checking if a certain program or its dependencies are installed on the specific hardware or operating system, listing files and folders that have a certain naming pattern, or maintain a ledger or history of previously executed commands. In advanced shell scripting, you can also use the shell along with its commands and utilities for text and data processing. You can also enable and revoke data access permissions to a set of users who have accounts on your specific operating system. You can also configure and schedule program executions, thereby starting or stopping programs of interest from the shell itself. Now let's take a look at what happens when a command is running. When a command is in execution mode, or when it's in run state, the program is called a process. A process gets a unique identifier or a process ID, abbreviated as PID. The kernel, which is the core of Linux, controls and manages processes running on that specific system. Every process maintains information about the program and all the background material that are required for that program to successfully run. We will dive into our hands-on session with our first command that would let us get an idea for all the processes that are running on this specific operating system. Now we are switching back to our shell. Since the shell already has some text on it, there is a command in Linux that will allow you to clear this text. That way you have a clean slate to start. The name of the command is clear. So when you type clear, it's going to get rid of all the text that appears on your screen. Anytime you're about to use a Linux command or a utility, you can always request for some usage information and also meta information about that command. The very quick command that will tell you what that command actually performs or does as function is the what is command. The what is command followed by the command for which you would like to get some extra information, in this case the clear command, gives you top level information about the function this specific clear command performs. In this case, it says that clear the terminal screen, clear all or part of the cursor window, and this is what this clear command does. Well, if you'd like to know more about how to use these commands, what options and what arguments are available, you can always refer to the manual page of that specific command. And to bring up the manual page, you'll use another command called man, followed by the name of the command for which you would like to know the usage. Here you can clearly see that the clear command, its description is clearly mentioned here, and then you also have a lot more options. Alright, since now you've taken a look at the first command clear, let's go ahead and execute it again. That way we'll have a clean slate for us to proceed. Alright, since our focus was the ps command, we'd like to take a look at what a ps command can do for us. The ps command, with its many options, displays a list of processes currently running on your machine. So when you type what is ps, it's going to tell you what it does. It reports a snapshot of all the processes running on your machine. Well, let's take a look at the manual page for the ps command with the command man space ps. Of course, it gives you the top level description, and it has a more elaborate description of the command, and it also has some options for you. It says you could use the ps aus option for the ps command to list all the processes that are running on your specific machine. Let's try out a quick ps command to figure out all the programs that are running on this specific machine. So we'll do a clean slate first, we'll clear our screen, and then let's do a ps minus aux. But here you can see that there's so many programs that are currently running on this specific machine. Well, this is a shared resource, so you will see a lot more users running their programs on this machine. If you would like to narrow down your search to just programs that are currently running on this screen, you can always do a ps alone, and that's going to list only those programs that are running within the screen. As we originally discussed, every command has a process ID. So here you can see this specific shell where we are executing the commands, it's by itself is a process. So that bash shell has a process ID associated with it. You could type more commands on the same screen, and you can see them being listed as separate processes on this terminal. So when do you use a PS command? You typically use PS command to check if a program is currently running, or if an executed program is running out of control or is depriving the machine of its resources like memory and computational power. There are times when you like to interact with that specific process that is running and give it some special instructions, like you would like to stop a process from running. As an example, we'll use a combination of 3 commands to show a process. We'll start a process on this specific terminal, and we'll get a handle to that process, and we'll see if we can send a signal to that process for it to get interrupted and stopped. To do so, we'll be using a combination of 3 programs or 3 commands here. We'll do the PS command to list all the processes that are currently running. So we have only 2 processes running at this time. Let's use another command called sleep. So this command sleep, of course you always would want to do a what does it do, right? So it delays for a specified amount of time. And let's look at the usage for this sleep command. So you would go back to your man page, and this gives you an option in here. So as you scroll down, so to just give you some background about the man page, a man page is more like every single page in a book. So for you to move from one page to the other, you'll have to hit your space bar, and that's going to take you from the current page to the next page. In this case, the sleep command takes a number as an argument, and it's going to let that terminal sleep or go idle for those many seconds by default. So you can see here, pause for number of seconds. So let's go ahead and clear our screen. Execute the PS command to make sure there's no other program running on the terminal. Let's execute the sleep command. Well, now the command is running, but you can see that you've not gotten the prompt back to your $, which is your bash prompt. What that means is the program is currently running, and you'll have to wait for it to complete its operation. In order to start a command and have it running as a background command, that means you have access to the prompt again, you can always complete your command with a $. Sorry, with an ampersand. And that is going to start the program as a background process. And what is going to return to you as a response is going to be a process ID associated with that specific process. Now we let the program sleep for 5 seconds. Let's do the PS command to see if it can list that specific command. Since it's already past 5 seconds, the chance that the program would have completed. So it says that there was a program by name sleep for 5 seconds that got done. In order to list that program as one of the processes running in this terminal, let's increase our sleep time. So from 5, I'm bumping it up to 15 seconds. Now let's do the PS command to show that specific process. Now we have the command PS currently running, and it's got a process ID 29214. Now let's assume that this is some program which is a runaway program, which should not be running for that long. So one of the first things that you would like to do on programs that are running out of control is to stop them from running. So there's a command, kill command in Linux, that will let you stop existing commands from running. So before we do that, let's make sure the PS command, well, the PS command is completed again. So let's start it for another 15 seconds. Make sure it's running. Now let's use the kill command to terminate this process. So the kill command takes in the process ID as one of the arguments. And it will terminate it. So here you can see the sleep 15 command was terminated. So these are some ways of interacting with an existing process that is running within your terminal session. Now let's move on to the type of commands now. In Linux, there are three different types of command options that we've got. So it's the simple command, there is the complex command, and there are the compound commands. A simple command is something that can operate by itself without the need for any special instructions. For example, let's do our clear first to clear the screen, and let's execute a simple command called date. The date command displays the current day, date, time, and year. Upon completion of the date command execution, the terminal prompt returns back to your bash. So you can clearly see that this recording is done on the 29th of September, which is a Friday, and it was done at 9:32 a.m. and we have resolution up to the seconds here. Another example of a simple command is a who command. A who command, without any extra information or extra arguments, is going to list all the users who are running on that specific machine. And clear is another example where you don't specify any other arguments and it can run by itself. So to just summarize, both date and who are simple commands that can execute with just its name and not more instructions. Let's take a look at some complex commands. Complex commands take additional instructions or arguments as part of its command line operation. Now, an example of a complex command is who am I? So this comprises of two parts. You have the simple command who, which takes two additional instructions, am I, and it's going to reformat the output we get from the who command and format it into a different way and present it to you on the screen. Here, the difference you can notice between the who command and the who am I command is it has taken the output of the who command and it has reduced the amount of information that gets thrown onto the screen, and this showing just the main user, which is myself here, and I'm connected to this terminal on this date starting from this time onwards. So here is a complex way of writing commands. Typically, you have the command and you have the corresponding arguments that go with that simple command. Now let's take a look at the third command, the third type of command, which is a compound command. A compound command is when multiple separate commands are put in a sequence of execution. For example, as we've seen the date command, you could do the date command followed by the sleep command for a few seconds. Followed by the date command. So now you have three separate commands that you executed on the command prompt. You could stitch all these three commands into a single command line argument and specify it in that specific sequence or order of execution. And as part of stitching them together, the default separator character used to separate these individual commands in a compound command structure is a semicolon. So the way I'm going to stitch all these three commands together into one command line operation is I'm going to run the date command. I'm going to have a separator for the next command. So here is an example of three separate commands that will be executed in this specific order, and the semicolon is going to tell where the previous command starts and where the next command begins. So here you can see, since we are asking this program to sleep for 5 seconds and we are printing the date prior to that sleep command and after that sleep command completes, you can see that there is a second difference of 5 seconds here. So you can clearly see that the sleep command did work, and it's showing that there's a difference of 5 seconds between the output of these two date commands. Before we move on to the next set of exercise, let's go ahead and do a quick refresher here. So I'm going to try out a new command called tree, which is going to let you look at the way files and folders are configured at a certain directory within your Linux file system. So for that, I'm going to use a command called tree and give it certain arguments. So when you type what is tree, it's going to tell you that it's a command that would list contents of directories in a tree-like format. Of course, reading the man pages, you'll find more information about that specific command, its argument, and its options. So here, the tree command, we are supplying two sets of arguments and options. As you can see, there's a tree to which we are specifying that specific option -L. We give it the argument 1, and we are giving another option -D, which is the directory where you want to see the structure of the files and folders. And you specify the path of that specific directory. Let's go ahead and execute this and see how the output looks like. Tree -L 1 -D This command is going to tell what are all the sub-contents of that specific directory /user. A slash is the root location of any Unix or Linux-based system. Here we are listing the contents of the USR directory, which is contained within the slash or the root location of your operating system. You'd like to know a little bit more about what this option L is. So you'll always go back to your man page for that command. And you can always use the space bar to page down. You can scroll to that specific option -L to see what it really means. Here you can see the -L option is going to display the maximum display depth of that tree. So if you set it to a value 1, as we've done here in the previous command, so you could always use your up and lower arrow to go back in history to seek back to a previous command you executed and re-execute that command. So it maintains a ledger or a history of all the previously executed commands. So this -L option with the value 1 is going to list all the immediate files and folders contained within this top level /USR folder. Well, you could increase this value to a 2, and that's going to list the top level folder and the contents of every single contained subdirectory within that top level folder. And that will be a lot taller tree that you might have to deal with. Ideally, you would just go to that location you're interested in and see how the contents are formatted or what contents are available within that specific folder.